Hello everyone, this is Nitin Mohod and here we are going to discuss phototransistor, which is one of the optoelectronic devices. Phototransistor is a three-terminal semiconductor device, as you can see in the diagram, which converts the incident light into photocurrent. Light is incident on the base terminal and the current flows from collector to emitter. It is a combination of photodiode and transistor amplifier. As the current obtained through photodiode is low, it is sent through the amplifier. Symbol of phototransistor is as shown, where arrows indicate the light incident on the base terminals. This is the symbol in case of NPN phototransistor. As you can see, the emitter lead arrow is going outward, while this is exactly opposite to it, which is a symbol of PNP phototransistor. So far the construction of phototransistor is concerned, here the base region and the collector region are large compared to the normal transistor. Base area is large to generate more photocurrent. As more light falls, more will be the photocurrent. Earlier phototransistors were made up of silicon or germanium material, while recently phototransistors are made up of gallium and arsenic to obtain higher efficiencies. Phototransistor is placed in a metallic case with a lens is kept on the top so that the incident radiation should be focused on the base region at maximum, and this lens kept on the top of the case in order to absorb the maximum incident radiation. Working of phototransistor, here the base is not provided with any external bias, as you can see, while only the incident light is there on the base region or terminal. Plus VCC is applied to collector and output is taken across collector and emitter. When no light falls on the base terminal, only the leakage current flows and that current is termed as dark current. When light is incident on the base collector junction through the lens, base current is generated, which is proportional to the intensity of incident light. Characteristics of phototransistors are plotted between collector current and the voltage between collector and emitter. And here you can clearly see from the graph that collector current varies with the intensities of incident light. The collector current increases, as you can see here, with the intensity of incident light. Collector current differs with the wavelength and the intensity of the light. Some of the characteristics with advantages, disadvantages and applications are as follows. In advantages, we can say it is the transistor having high efficiency, then fast response, less noise interference, low cost and small in size. While the disadvantages are poor performance at high frequency, slower than photodiode, and applications, we can say it is used in counting systems, used in optical tape recorder, then to detect object, and also used in printers. I hope the idea about the phototransistor, its construction, symbol, working and characteristics is clear to you. Thank you.